Refractometer. A brief introduction of the machine itself. Polarizing filter. Removable magnification. This is where you're gonna see all the numbers. And open up, you have something to block the light. So if you're buying the refractometer, clearly this one has a big logo on it. I got it from GIA. They are very good quality, but they are a little bit on the pricier side. If you are looking for something like this and you don't want to break the bank, you want to get it secondhand on eBay or something, just make sure that this piece of glass right here, where you put the gem on top, is not scratched. If it is scratched, it will influence the result a little bit. This machine is not the only one that you are going to get because it requires a little light portal that produce monochromatic light. White light will also work, but monochromatic light will show the result much clearer. So today, without too much being said, let me show it right now. Here is our special guest today. I broke them down to 4 tiers. Tier 1 will be the highest RI. So RI stands for refractive index. And the higher the refractive index, the higher the dispersion. So that's why you will see some almond garnet, sphinx, and also zircon, which I don't have an example right here, and also diamond. They will produce a high fire. So that's where the fire comes from. High dispersion, high RI. OTL, which stands for over the limit. Most of the refractometer will read up to 2, but this one from GIA actually only reads up to 1.8. Above 1.8, I will consider it OTL, which is actually not that many gemstones. That's OTL. Moving down, we have tanzanite. It has a refractive index of 1.69 to 1.7. It's doubly refractive. Rhodolite garnet, around 1.76. Moving on, we have topaz, around 1.62 to 1.63. Even though they are different color, different inclusions, but they will have the same RI. So a lot of the time, we will confuse blue topaz with aquamarine. Reading the refractometer, we can clearly separate topaz with aquamarine. Aquamarine has a lower RI than topaz. Last but not least, the quartz. As we know that quartz have so many different varieties, these two will have the same RI even though they are different varieties. So by using this machine, we need this, well, it just says refractometer liquid, but can't remember the name of the composition of it, but without this, you will not be seeing the correct RI on your refractometer. One of my colleagues says this is liquid gold because it's so expensive. This little bottle costs $90. Do not inhale this or touch this because it has a warning on it, and which I didn't follow that much because it smells really good. I guess this is when you find out that you're made for this job. Comes in a little adapter like this. So this adapter will only hold 1 drop of the liquid. Convenient for put it onto the glass piece of your refractometer. Now it's on. You only just need a little bit because it's liquid gold. So depending on how big your stone is, you apply the amount. So here I have a little drop. Right now, we are going to go with gemstone number 1, almond garnet. Faceted stone is very easy because you have a flat surface. But before you do this, make sure that you have no grease left on the gemstone. What I like to do is find a piece of paper, rub it like this, pick it up with the tweezer, making sure that this is polished. Gemstone I have right here is an oval shape, so we know the direction very clear. So once we have the stone inside, we're 1.8. In this case, this stone is OTL. We have to test all the different angles. We write down all the results, then we add it, find the average number of the RI. So in this case, we already know it's a garnet, so we know it's not doubly refractive. For the refractometer, there's also another great way to test whether a stone is doubly refractive or singly refractive by finding out the birefringence. How do we do that? Magnification first. We use polarizing filter. We are going to see a little jump between the numbers. It's a doubly refractive gem. In this case, it's OTL. Obviously, it's not going to show. And then garnet is a singly refractive gem. Therefore, we are not going to see that. Moving on to cubic zirconia. So CZ is a little bit transparent. Therefore, I'm going to close the lid to block all unwanted light. It reaches 1.8. That indicates OTL. Usually CZ will come in 2.15 to 2.18. Well, this is our old friend, Sphene. Sphene is very OTL as well. Well, since Sphene is a doubly refractive gem, therefore, it does show some birefringence, but since it's OTL, so there is no point to test it. So moving on, tanzanite. Finally, it's not OTL. So voila, 1.69. So if we add the magnification glass and also the polarizing filter, watch that little line when I turn this. That's why being a gemologist, you need to have good eyes, actually. So watch that line carefully. Just about 0.005, 0.69, 1.685. And why do we have to check all angles? Because it could read different numbers, since it's a doubly refractive gem. The same piece of tanzanite, now it reads almost 1.7, 0.695 I would say. And then once you turn the polarizer, here's the 0.005 jump. Here it jumps between 9 to 9.5. So even though rhodolite garnet is the same species as almandine garnet, but it has a different RI reading due to their host rock. 1.76. Moving on to topaz. Topaz has a lower RI, 1.62. Once you turn the polarizer, you see a tiny little jump right here, about 0.08. Usually people cannot tell the difference between topaz and aquamarine. The refractometer never lies. 1.58, much lower than a topaz. So now we're in the quartz family. Today I don't have a gem that's lower than quartz. Glass or plastic imitations, that's very low. Opal is kind of low. Amber has very low RI as well. I am going to show you the amethyst first because it's faceted. 1.55. Last but not the least, cat's eye quartz. For cabochons, you can see that we have a round surface, and in this case, we will do something called spot reading. We will find the most concave, most sharp corner of the cabochon, and then of course we rub it to clean it. Then we just do a tad bit of the RI liquid. Then we move around that liquid until we find it on the scale. My apologies for my shaky hand. Here you can see a little spot. Oh my gosh, it's so blurry. Well, since the camera wasn't picking up very well, I'm just gonna show you what looks like on the textbook. So what you will see is you will see this little black dot, and then there's 3 scenarios: gradually fading, or you will see a jump, or you will see it fading. So most of the cases it will be this type, which is the most accurate actually. You see the line that's perfectly in the middle. This is where your reading is. So yeah, besides the refractometer itself, testing the refractive index is definitely the most important part in identifying a gemstone. If there's only one machine that you can afford to start your own little testing, I guess, I suggest you to go with a refractometer. Oh, actually, you know what? Buy the loupe first. That's more important. Thank you so much for sticking around for season 2, and thank you for all the support and also the questions, which I love to answer. Anyway, hope that helped. Bonne nuit!